Factoring is an important part of math and is really important when we start dealing with algebraic expressions. So example 1 says, which of the following statements are true? Here we're factoring numbers. We're looking at the number 24, and 24 has quite a few factors. And factors of 24 are going to be 2, 3, 4, 6, 8, and 12. Well, that is a true statement. I'm going to put true here. Prime factorization of 24 is 2 to the power 3, 3 to the power 1. Well, that means that's 2 times 2 times 2 is 8, times 3 is 24. That is, they are all prime numbers, so that is true. And looking at statement 2, well, the prime factors of 24 are 2 and 3. Well, referring to statement 2, that must also be true. And root 24 is an irrational number. Well, irrational numbers are any numbers in the roots that are not perfect powers, in this case, perfect square. So 24 is not a perfect square, so that is true as well. So here, all of these are true statements, so the answer is D. Number 2 says GCF LCM. So GCF is 8, LCM is 112. Well, the GCF, well, there's definitely a bigger number than 2 for the GCF, and 7 is not even a factor, nor not even a multiple of any of these numbers. So we can immediately eliminate A. Taking a look at D and C, well, we have 896. That cannot have a multiple that is smaller than itself. So this must not be true. And in this case here, we have a GCF that is bigger, and C, a GCF that is bigger than 8. Well, that's not possible either. So that's not true. So we're going to eliminate C and D as well. So what's left is B. So clearly the answer is B, but we should check it. Okay, so the GCF, the greatest common factor of 16 and 56, yeah, the greatest common factor is 8. The lowest common multiple, well, 56, the first multiple is 112. 116, if we skip count 116, we end up with 32, 48, 64, 80, 96, and then we get to 112. So that is definitely the first multiple, because 16 does not have a multiple of 56. So the next multiple, which matches, which is 112, is correct. Looking at 3, which of the following is a visual representation of x plus 3 times x plus 1? Well, there's two factors here, so this must be a length times the width, and that means that the area must be a rectangle. Okay, so given that criteria, we can see that, first of all, C does not meet that criteria. So looking at C, we're just going to eliminate C right from the get-go. It's not a rectangle. Same with D. D is not a rectangle. So we're just going to get rid of those right away. Now taking a look at B and A, well, looking at B, there are parts of B that just don't quite make sense. So this part of B here, that should be 3 times x and give us 3x's. That is not 3x. So this shape here, first of all, is inconsistent. This doesn't really exist. Same with this bottom piece here. That should be 1 times 3. So we have 1 times 3. And that should give us a shape of 3 ones. And again, that is also inconsistent. So the answer is A. And looking at A, yeah, we have x plus 3 along the horizontal. Okay, we have x plus 1 along the vertical. We have x squared, 3x, 1x, that gives us the 4x's. And then the 3 times 1 gives us the 3 ones here. So this is consistent. So the answer is A.